All right. Okay, here we have exploration 2 of lesson 4. So this is talking about explaining accuracy of weather predictions. So this talks about how a weather forecast is a prediction about what will happen at a given place or a time. And it says, have you ever used a weather prediction to decide what to wear? Talks about how people use weather forecasts. Pilots rely on forecasts to navigate planes. Um, and then it gets to this table. And it says, this weather chart shows past and current temperatures. Try to predict the temperature for Friday. So it's 5 degrees, 0, 1, -2. So I said -1 is my prediction. And then it says, what did you base your prediction on? I just guessed. I mean, there's really no data here. I know from just life experience that it could be warm and then get cold for a couple days and then be super warm the next day. So who knows what the next day would be if this is all I have to look at. It's obviously not weather outside, so I can't even look at the clouds or anything like that. Um, so I'm just guessing, but it looks like it's getting colder overall, and so I kind of picked a temperature that was a little bit warmer than this, but still cold. Maybe it's going to get a little bit warmer. Um, but other data that I would want to use, right? What would be helpful to have for other data? Well, it might be nice to, I say these things in here, but it would be nice to have, like we have up in here. Oh man, I have to scroll so far back. Sorry. Like it might be nice to have one of these types of maps, right, where you can see warm fronts and cold fronts and see how the clouds are moving, see pressure systems. Anything like that would help to make a better guess as to what the weather would be like. Even something like whether it was cloudy or whether it was clear. Um, maybe this day it was really clear outside. There weren't any clouds. But, if you lived in this location, you might see how a bunch of clouds were coming in that day. And if this day was going to be more cloudy, it would be warmer. Because in general, clouds will make it a little bit warmer. It acts like insulation in the atmosphere. So, even something like that could help you predict more accurately. Do I think my prediction would be accurate within a degree? Absolutely not, because in this case, right, I'm just guessing using previous temperatures. I have no other information. So I don't know. But I would say maybe within 5 degrees, definitely not within 3 degrees, but maybe within 5 degrees. Because, this day went from 5 to 0. So just off the last few days, it seems like that's been the biggest temperature change. And that's a pretty big temperature change, so maybe 5 degrees it would be accurate within, but definitely not 1. So down here it's talking about data used in weather prediction. So it's talking about make weather forecasts. You use past conditions, current conditions, and sometimes even past conditions. Past can mean the past few days or, years back in time even. Um, and they also take into account current locations and movement of air masses, fronts, high-low pressure systems. So a lot of times when you go to a forecast, you'll see something like this, obviously, where it has little graphics and the high and the low temperature and the little description of whether it'll be cloudy and whatnot. But then it also has the chance of precipitation, which is usually, this is calculated from the humidity. So they take the humidity and they do other calculations to figure out, what are the chances of it raining. And then they a lot of times will show you the wind direction as well. And so I highlighted, I think, the two most important things here. So I highlighted that weather forecast models are based on physical laws that determine how the atmosphere works, and they're mathematical models that contain many related equations. So what this means by physical laws that determine how the atmosphere works, right? We know that a physical law is, if you have a low pressure system and you have a high pressure system, that the air will generally be moving from the high to the low. That is a physical law. We know that that's going to be happening. We know that the warm air, excuse me, we know that warm air is less dense. So we know that warm air would rise while cold air would be sinking, right? These are really basic physical laws, things that we know, and they take simple laws like this and they combine them all into many related equations. So they're taking lots of different things like this that they know, putting them all together and making these models that they use forecasts for. And this talks about, and then down here it says 5-day forecasts can be made with about the same level of certainty as a 2-day forecast could 30 years ago. This is due to the continual improvement of weather forecast models and the increased speed of supercomputers. You don't even need a supercomputer to do forecasts these days. But it talks about up here, people used to actually make all of these equations, but they would have to solve things by hand. So they would be sitting there, in their weather room places, doing all of these mathematical calculations by hand to try and solve things, or even using calculators. But they had less assistance, and so they would have to be putting these things together all themselves. Now we've got computers, you can program them to do all sorts of things at the same time, and so they can take in much more complicated equations, and they can uh, essentially do more work in the same amount of time. So our 5-day forecasts are pretty accurate now, in comparison to what we used to be able to do in the past. And our 5-day forecasts are essentially just taking their computers, taking all of this information and patterns that we've seen, and now we even have like computer learning and stuff where their computers look for patterns themselves, and they can help predict the weather. So this is an evidence notebook entry and says how do forecasts use mathematical models to make predictions about future weather conditions. So this right here is really asking you to summarize all of this stuff from up here. How are they making future weather conditions? So I said, scientists build mathematical models based on physical laws such as the pressure, and they can combine the physical models and use computers to run these models and predict accurately what's going to happen. And because computers are improving, the predictions are also going to improve. We can do more complicated things. So limitations of weather forecast models. So they're rarely 100% accurate, right? Weather is a complex phenomenon that is affected by many factors, and weather forecasts involve probabilities and percentages. So oftentimes you see in weather forecasts, like up here, right? These are percents. Why are they percents? Because they're probabilities. So it could not rain this day. There's a 10% chance it's not going to rain, but it probably will. And the reason why they use percents is because percents, right, are a mathematical probability. Probability is something we talk about in math a little bit later this year, quite a bit. But like the probability of flipping a coin is 50-50. It's a way to measure the chances of something happening. And so we oftentimes use probability and percents to measure weather because it's not exact, right? We're using models and we're predicting things. We're not saying it's going to be rainy. We're predicting it's going to be rainy. And then this down here says, look at this forecast for Truckee, California. That's, if you don't recall, that's up in Tahoe. It's if you drive to Tahoe up 80, the highway that we live by, and then you drive, like it's before you get to the, never mind. Anyway, Truckee, it's up there. So it says compare the predictions to what actually happened. So you'd have to scroll back up here and look at it's happening, right? And you're comparing all of these, what it said right here, to what this is. This is what really happened. The thing above was the predictions. And so I said, The high temperatures were pretty close. The low temperatures ended up being not as low. So I think in the what I meant by up here, see, it says that this is going to be 30 degrees and 18 degrees in the prediction. But down here, it only got to 22 degrees overall. Let's see, it says that the humidity on Thursday ended up being higher. This was a higher humidity. And this says explain why it's still useful. And so you can see how some things are pretty close. I think the wind was pretty close. Uh, but yeah, the wind was almost exactly the same. Uh, so although the whole forecast overall wasn't exact, it's still really useful because you still know 15 miles, 17 miles, 21 miles, like this is pretty windy still. So you could still tell it's pretty windy, right? You still know, even though the low was 22, not 18, I mean, that's pretty close as far as we can feel ourselves. So we would still be dressing the same, right? If we were prepared for snow and rain on Friday, then you'd probably also be prepared for it on Thursday. You wouldn't be caught off guard if it started earlier on Thursday. So, these types of predictions can still be useful to people, even though they're not 100%. And why do weather forecasts have limitations? And so this is just reiterating, talking about again how, forecasts are predictions. They're using mathematical models, and so they're limited because we're trying to take something super complicated. Weather is super complex. There's that theory where they say, a butterfly on one side of the world will create a hurricane or a thunderstorm or whatever on the other side of the world the next day because the wind from their wings flapping will change the whole world. It's kind of overblown idea, but you get the idea is how like some small little change, all these little small changes affect the whole. So it's really hard to predict them accurately, but they're still useful because it's still nice to know when it's cold the next day. So then you're using this map to make some predictions. So this is Thursday. We have Friday here. Interpret the, well, okay, these show the predicted weather. Okay, so if you read up here, it tells you that this is the 2-day weather forecast up here. Right here, 2-day weather forecast. Results. And they say these were produced on a Wednesday. And hold on. Yeah, so I said predicted because it seems like when you're reading it, it might be in the past, but the maps were produced, right? These were produced on a Wednesday for what the Thursday and the Friday would be. So they were predicting what the weather on Thursday and what the weather on Friday would be on a Wednesday. Yeah, that's right. Okay, there is a cold, warm, or stationary front moving towards Texas. So here, obviously here's Texas down here, and these are the fronts. There's this front right here, and this one right here. Remember that they move in the direction that they are pointing. So this cold front is moving like in this direction, and this one over here is moving in this direction. So no matter which one you're talking about, there's cold fronts moving towards Texas. Erase those so they're not cluttered later on. And from Thursday to Friday, you can see the precipitation along this front increases or decreases. So this is Friday. It's saying, well, here's Thursday, and then here's Friday, and what happened? Well, you can see over here, right, this color-coded thing talks about heavy to light precipitation. So all in here, right, and this is still in Texas, right? Now all Texas is, especially in this area, it's green, orange, red coloring. So that's all pretty high amounts of rain, precipitation going on. So it increased. There we go. And We got this 17 act you don't really need to worry about because it's meant to be done with people. 18, complete the descriptions to explain the limitations of weather forecast model that produces these steps. So the accuracy of these models decreases with time into the future. Therefore, the future forecast results for Thursday are likely to be more accurate than they will be for Friday, which is saying like this Thursday's prediction is going to be more accurate than Friday because Friday is further out into the future. And so the farther out into the future you get, your predictions are going to be less accurate. So Thursdays is going to be more accurate than Fridays. And the model shows the amount of precipitation with colors. So you can tell that there's going to be more, right? This over here, and it also says precipitation amount. It tells you that there's going to be more rain, but it doesn't say how much more rain because they can't tell that. And finally, analyzing weather forecasts. I think this is the end for this one. Yes. So 19 says, cite evidence from the text in this map to explain how this forecast could be useful. And I said that the forecast would be pretty accurate for the meteorologist, right? You're responding to all of these things up here. So I'm saying it would be accurate for the meteorologist, and that the meteorologist could be very, very confident in it because this forecast is only a 24-hour forecast of precipitation. And so based off of first of all, we know that predictions shorter out are going to be more accurate, but just based off of the fact that we're assuming that this precipitation forecast is being built off of, more than just looking out the window wherever the person lives, and they're using, probably radar and the pressure systems and everything to make them out. It's going to be really accurate because this is what's happening in the very near future, and you can measure all the pressure systems and everything right now. So the next 24 hours, it's going to be really accurate. And then based on this map, what travel advice would you give to someone visiting the beach in Oregon? Don't go, or unless you like to be in the beach when it's rainy, or you should wear lots of rain gear because this is Oregon right here, and it's either dark green or this medium green color. So you've got 80 to 100% chance of rain the whole day. So that sums up Exploration 2.